Okay, so we're going to start working with alcohols next. And before we even start looking at them, I just want to show you what their structure would look like on a model kit. Notice here we have 4 carbons in a row. Obviously, your single bonds can rotate. And with an oxygen, which an O and an H make an alcohol, this is not a linear type of arrangement of these atoms. And the reason for that is that if you recall, there's 6 valence electrons in oxygen. So technically, there are hybridized electron orbitals there and there. Okay, now that's way big for what we have here, but those are taking up space. And so that's why this bond does have a bit of an angle right there. Okay, now let's talk about how to name some of these guys. So as I said, an alcohol is going to end in an OH. And what we do to name them is, if you have a regular chain, we take off the E from the end of the name of the chain and we replace it with ol, OL. So that means that what I just showed you actually, and what this molecule is 1, 2, 3, 4 carbons with an OH. That is butanol. Now, just a reminder, when you draw a line to something that's not a carbon and you identify that as not being a carbon, that does not count as a carbon in the chain. So there's only 1, 2, 3, 4 carbons right there. Same thing works within a ring. Now it does, it is relevant to know that the OH is assumed to be on number 1, because whatever this OL means, like the end of the word, is that should take sort of the highest priority, which means the lowest number. So again, this would just be cyclohexanol. It's the same thing as 1 cyclohexanol, but yeah. Here it's 2 pentanol, so 1, 2, 3, 4, 5. It's easier to count from this direction to get the lowest number for that OH. Here we've got 3 bromobutanol. Okay. This might be a little bit more difficult to see. We need to start counting from this direction. 1, 2, 3, 4. There's only 4 carbons in that chain. The OH is on the first one, which is assumed, but you can also write that in there if you want to. That's totally fine. So it would be 1, 2, 3 bromobutanol. Okay. Next we have 2, oops, I forgot an H there, 2-methyl. There we go, cyclohexanol. And the OH is again assumed to be number 1 in the ring. We can also have what's known as thiols. So you can have 2 OHs right there and there. And you would just signify that by putting diol at the end instead of just OL, which would be a single alcohol. We have to tell people where both of those are located though, and that's why we say 1, 3. So this would be 1, 2, 3. Okay, good. In a very similar way, we can name thiols, and thiols end with SH instead of OH. If you notice, sulfur is right beneath oxygen on the periodic table, so their properties are even pretty similar. Okay, so here we go, 1, 2, 3, 4, 5. Instead of having an OL, we have a THIOL. That's the thiol. That takes number 1 priority because of the fact that that's the lowest number that we can give the end of the word. So 1, 2, 3, 4, 5. It becomes 3 fluoro, 1 pentanethiol. In a ring, it's very similar like what we had with an alcohol. This is simply cyclobutanethiol. And here we have something a little bit more complicated. We've got 1, 2, 3, 4, 5, 6, 7, 8. Now if I count this way, that gets a 4. If I go this way, it goes 1, 2, 3, 4. Methyl gets a 4. We don't want that. We want this to have the lowest number possible. So this becomes 5-methyl 4-octanthiol. Okay. Now, you might also see some SH dealt with as a mercapto. There's all kinds of common names for these types of things, and you can use SHS mercapto several times with IUPAC, but as far as I'm concerned, I really want you to focus on knowing the IUPAC terminology. There are some common names that you might want to just know, but for the most part, I'm focusing on IUPAC nomenclature, which makes a huge difference when it comes to ethers. Actually, and the easiest way to look at an ether is down here. This is known as diethyl ether. Now that's the common name. But we kind of almost even consider it IUPAC because it's so common. But this is something that we use a lot of in the laboratory. So what this actually means is that there's an oxygen right there, and we've got an ethane on this side of that oxygen and an ethane on that side of the oxygen. So that means that we've got carbon chains that are coming off of both sides of that oxygen. But we don't really name it like that because that's more of a common type of nomenclature. So this sounds way more complicated as to how to name it than it really is. So instead of going through this, I'll let you read that. Let me show you how the easiest way to do it. You've got an oxygen that's connected to more than one carbon chain. That's an ether. That's what the definition of an ether is, okay? This chain is longer than this chain. So we determine that this is the parent chain. That's the longest snake, and he's what gets the end of the word, right? And then this guy, along with the oxygen, we call that a substituent. So if this would be a methyl, and it's got an oxygen attached to this 1, 2, 3-membered chain, this entire thing right here becomes a methoxy. That's why we call it methoxy. And then the end stays propane. So let me show you another example. This is still propane, 1, 2, 3. So that's the longest chain between these two. So that gets the end of the word. There's 2 carbons here. That would be an ethane, but since it's attached to an oxygen, this is considered a substituent. That's ethoxy. Here, ethane is the longest chain, and this would be a methoxy substituent. These can get more complicated though, right? Okay. Here my longest chain is 1, 2, 3, 4, 5, 6. That's hexane. Just like this would be as isobutyl substituent. Remember, 1, 2, 3, 4 carbons there. And there's a forked tongue at the end, right? So this would be an isobutyl, but when combined with oxygen, it's isobutoxy hexane. That sounds complicated, but you got it. This one hopefully is a little bit simpler. We've got 1, 2, 3, 4, 5, 6, 7 carbons on this direction. We've got 1, 2, 3, 4 on this direction. So this is the parent chain, and as well you name the end of the word here. So that's heptane. And this is your substituent. And since there's 1, 2, 3, 4 carbons coming off of there, that's a butoxy heptane.